Hello everyone. This is the last acidic comparison in the chapter of phenol. Compounds are normal phenol. This is ortho-methyl phenol. Ortho position methyl is there. This is meta-methyl phenol and this is para-methyl phenol. If I talk about IUPAC naming, numbering will be done. Least number will be given to functional group, then side chain. So 2-methyl phenol, this will become 3-methyl phenol, this will become 4-methyl phenol. One more common name is there for them, which is very, very important. We used to call them ortho-cresol. This is Meta-cresol. And this is para-cresol. Learn them because mostly the questions are given to us in the form of these names. Ortho-cresol, Meta-cresol, para-cresol. These are their common names. Let's start to compare them, their acidic nature. Technique will be same. I will make oxygen anion and I will compare their stabilities. But before going for the stability, one effect is there which you should know because that effect is present in this molecule and it is not discussed with you. Actually, this effect already you have done in 11th class, which is known as hyperconjugation effect. Hyperconjugation can arise in three cases: carbocations, carbon free radicals, and alkenes. Because you can check in benzene ring, benzene is nothing but a alkene, a cyclic alkene. So in alkene hyperconjugation is possible. So I am going to discuss this alkene case. This I will not discuss in this video. This I will not discuss. Alkene directly. Now in alkene, how hyperconjugation will arise? What is the condition? Condition is very simple. Doubly bonded carbons. Obviously in alkene doubly bonded carbons are present. Alpha carbon should be there. What is alpha carbon? Next to doubly bonded carbon is known as alpha carbon. This is alpha carbon and obviously this will carry a hydrogen. Here also hydrogens are there, but I am not writing them because they are not useful for me. Draw by yourself. So in hyperconjugation, what is happening? This alpha carbon temporarily breaking bond from hydrogens, like first hydrogen, it is breaking bond from this hydrogen and it is going to shift them here, due to which these pi electrons will move temporarily to this carbon. So lone pair will come on it, negative charge, because one electron it got extra of this carbon. Here single bond will left. Now during this process, this carbon will have a vacant orbital because its electron has gone to this carbon. Vacant orbital will be generated like this. That vacant orbital will be filled by these two electrons. So double bond will generate here. And this hydrogen, because has lost its one electron, so it will become H positive temporarily. And what will happen next? This process will be reversed. Again, you will get this molecule. Now, next time hyperconjugation will be shown by this hydrogen. Same process, same repetition. Next time, this hydrogen will be included in the hyperconjugation. Similarly, and similar repetition. This process is known as hyperconjugation. Now, what this process is doing in cresols, check. I am not fully explaining the hyperconjugation because it's a topic of 11th class. I hope the students know about it. I am directly going to apply here. Now check why I am discussing hyperconjugation. You know, to check acidic nature, we need to make anions of oxygen. Okay, I have made it. Suppose CH3 group is present on ortho position. This one. Now first check, do we have a hyperconjugation condition? Yes, check. These are the two alkene carbons and this carbon is working as a alpha carbon here. So alpha carbon is present with alkene, means hyperconjugation possibility is there. So apply hyperconjugation. What is hyperconjugation? Right now I told you. The carbon will temporarily break bond from this hydrogen and will shift here, due to which these pi electrons will come to this carbon. So lone pair will generate on this carbon, and this carbon will carry a negative charge because it is carrying one extra electron, this electron of this carbon. Now double bond will generate between these two carbons, hydrogen as a positive, rest two hydrogens as it is. Now due to hyperconjugation, you can check this carbon is carrying lone pair. Now these lone pairs will repel the electrons present between carbon and oxygen, shared electrons. Due to repulsion, these electrons will move toward oxygen and oxygen's negative charge will increase, which will make it destable. Means hyperconjugation of a methyl group is making this oxygen destable. Is it possible from all positions? No, it is possible only from ortho and para position. Check. If I am making CS3 here on a para position, okay, draw resonance. No, we will not call it resonance, sorry. This is hyperconjugation. Electrons will come here. Pi electrons will shift to next carbon. Double bond here. Two hydrogens as it is. One hydrogen will become H positive and electrons will come on this carbon with a negative charge. Now next movement. This. Lone pairs will come in bonding and due to repulsion, these pi electrons will shift to next carbon. So again you can check. Electrons are coming on this carbon. Double bonds here and rest molecule as it is. No change. Now these electrons which are extra here on this carbon will repel the electrons present between carbon and oxygen. So these electrons will move toward oxygen and the negative charge of oxygen will increase. So these electrons are making it destable. Means from ortho and para position, hyperconjugation of methyl group will destabilize this oxygen, but not from meta position. Why? Let's check. Let's apply hyperconjugation from meta position. These pi electrons will move to next carbon. These pi electrons will go to next carbon. Double bond will here. Rest molecule as it is, no change. This one. Now these lone pairs will come in bonding like this and these pi electrons will move to next carbon. So you can check if CS3 group is present on meta position, due to hyperconjugation electrons are not coming on this carbon. And if electrons are not coming on this carbon, they can't affect the stability of oxygen. Means in conclusion, if I say hyperconjugation H effect, I will call it H effect, will destabilize our oxygen from two positions, ortho and para position. Simple. Hyperconjugation of methyl group will destabilize this oxygen only from ortho and para position, because if it is present on ortho and para position, electrons will come here, which will increase the negative charge of oxygen, but not from meta position, because if it is present on meta position, electrons are not coming on this carbon, so obviously they can't affect the stability of this oxygen. This is the point. Now let's apply it. Now let's come back to our main comparison. We were comparing normal phenol. So technique I already told to you. Release H positive ions and create anions. So this is the anion of phenol after release of H positive. And we are going to compare their stabilities. This is the anion of Ortho-cresol. This will be the anion of Meta-cresol. And this is the anion of para-cresol. We will compare their stability. Let's start the factors. Number 1, in every case we have this factor, plus R of O. This oxygen who is unstable can donate lone pair due to resonance in a benzene ring, so we call it plus R. And this plus R of oxygen will decrease the negative charge of oxygen. You know, after this movement, what will be the next structure? This. The negative charge will come on this carbon, and from oxygen the negative charge will finish. Only 2 lone pairs will left. Here was 3, so negative charge was there. But due to resonance, its negative charge is finishing, which we call plus R of oxygen. And this effect is available in all rest 3 cases. So plus R of O, plus R of O, and plus R of O. And because this factor is decreasing the negative charge of oxygen, so we will call it stabilizing factor. So I will write here S. Stabilizing factor. Now second factor which is present, substituent is not there, so no other factor, just cross it. Here we have substituent, CS3 group. Now first effect, hyperconjugation. From ortho position, right now I told you, from ortho position, when it will show the hyperconjugation, the pi electrons will come on this carbon, due to which the negative charge of oxygen will increase. Means it is destabilizing it. So I will write it H of CS3. Hyperconjugation of CS3. Which factor it is? Stabilizing or destabilizing? It's a destabilizing factor, D dot S. From meta position, electrons will not come on this carbon, means hyperconjugation of CS3 is not going to affect the stability of oxygen. So here I will cross it. Because hyperconjugation is not affecting this oxygen, so I will not write it. So this factor is not available from the meta position. From para position it can happen. So H of CS3, which is going to destabilize the anion, DS. Third factor, CS3, here the carbon is sp3 hybridized, and this carbon to which it is connected, it is sp2. Now sp2 carbon is more electronegative than sp3, so these electrons are going toward this carbon, due to which obviously these electrons will feel repulsion and they will move toward this carbon, due to which these electrons will feel repulsion and they will move toward oxygen, due to which the oxygen's negative charge will increase. CS3 group is losing electron, so which effect it is? Plus I effect. Plus I of CS3. And obviously it is a destabilizing factor because it is going to decrease the negative, it is going to increase the negative charge of oxygen. So it's a destabilizing factor. It is also available here. destabilizing factor. It is also available here, plus I of CH3, a destabilizing factor. Now you know plus I minus I, they decrease with distance. So I believe CH3 here is very close to the oxygen. So here plus I is strongest plus I effect. As the distance will increase, it will become weak. So it is weak here in meta condition, and here it is weakest. That's it. All the factors we have written. Now it's a time to conclude. Okay. So if I talk about these three as compared to this normal phenol, I believe all these three are destable, less stable as compared to this one, because you can check here only one factor is there which is stabilizing, and here you can check two factors are there which is destabilizing. So obviously these three are less stable as compared to this one. Okay, now out of these three, which is least stable, or we can say most destable? Please check my words. I am saying least stable, or I can say most destable. Okay, most destable anion will be this one, ortho. Yes, you can check. Hyperconjugation is destabilizing it, as well as plus I is destabilizing it. Here also two factors which is destabilizing it. One is hyperconjugation, one is plus I. But you can check plus I here is strong and here it is weakest. So definitely this anion, in this anion the oxygen's negative charge is increased highly. So this anion will be most unstable. Most unstable anion. After that, this will be most unstable because it is getting destability due to two factors, plus I and H. Then meta will be unstable, and most stable will be this one. So 1, 2, 3, 4. You can check, everything is written here. You need to just conclude it, sum it up. So finally, and if I talk about plus R of O, I already told to you in previous video that plus R of O is present in every anion. So it is not a factor which can decide the stability of an anion. So whether you want to include it or not, it depends on you. Only the main factors are generated due to substituents. So if I write stability order of anions in increasing order, so which is most unstable? Second one, ortho. Then fourth one. Fourth is more stable as compared to second. Third is more stable than fourth, and most stable will be 1. So what will be the acidic order? Already discussed many a time. The second molecule, this molecule, it was this, ortho-cresol. This second molecule knows that after release of H positive, let's release it, a most unstable anion will be generated among these four. So obviously it will resist to release H positive because nobody wants instability. It will resist to release H positive, it will become less acidic, least acidic if I say. Para-cresol will be more acidic than ortho. Meta-cresol will be more acidic than para. And normal phenol will be most acidic among these four because normal phenol, this molecule, knows that after release of H positive, I will get an anion which is most stable among these four. So obviously it will ready to release H positive very easily. If easy release of H positive is there, so this molecule will become When I'm saying this molecule, molecule means this original parent molecule. This molecule is ready to release H positive. So if it is easily releasing H positive, means it is most acidic here. So this will be the acidic order of these 4 molecules. That's it. This is the end of acidic comparison. Now in next video, one more point is there. On the basis of that, questions are being asked by board or in JEE and NEET that I will discuss with you. Thank you very much for watching the video.